Welcome back, everyone. In this video, we're discussing on the normal distribution curve. We're discussing on charts. We're discussing also on skewness and kurtosis. So we have the data sets already on SPSS. We have the data sets here on device owned, color, and other variables. So first, let's start with charts. About charts, we have many options. Of course, we click on Analyze, we go to Frequencies, then we go to Charts. We have bar charts, we have pie charts, we have histograms. The range of the data set determines the chart that is more or most appropriate for it. For example, if you have data set with too many categories, more than 3, 4, maybe it's entering to 5, you can't represent such data set on a pie chart because it might look clumsy. But data sets that are very minimal and you can clearly differentiate that one has magnitude more than the other, pie charts will be more appropriate. And of course, on bar chart, you can use that to show many categories. And histogram, which is also a media of showing normal curve. So let's start with pie charts. On pie charts, let's use gender, which is sex, because we have just 2 categories from this data set, male and female. So pie chart will be more appropriate to represent and to visualize that data set. So just we've set it here. In order to just click on set, then you click OK. Then wait in the data editor window and you see the results. These are pie chart, which blue part represents male, while the red section represents female. We can also have more charts. On this, the same procedure, just click Analyze, Descriptive Statistics, go to Frequency. This time around, let's use bar chart. Continue. Because bar chart is more appropriate when we have many categories. Let's take this out and let's replace it with device owned because it has many categories, 5 categories. Just click OK. Then hold on for it to come up. Now we have our bar charts. See, we have device owned, we have tablets, Mac, and we can even see from here that the personal computer PC is most owned by the respondents, and followed by Mac, then printer, then the little of them have either tablets or smartphone. So that's bar charts. But histogram has more features than just showing us the magnitude of increase or decrease, but it shows us also about the normal curve. So to conduct histogram, we can use that to find the normal distribution of a data set. So the same process, go to Analyze, go to Descriptive Statistics, go to Frequencies, go to Charts, go to histogram. Now you have a box below histogram that tells us to show normal curve on histogram. So just click on the box, then you continue. After you've done that, OK. Now, this is the histogram, the result of the histogram. And from here, we can deduce that histogram is on it a curve. We have normal curve on it. The normal curve, it's a symmetrical curve. It's a line of symmetry. It's a curve of symmetry, meaning that once it is parted into 2, either sides have similar features. So we see now that is a curve like a bell shape, which shows what normal distribution. And of course, look at the results to confirm that we have the mean value to be 3.07. We have standard deviation to be 0.9, which is far away from you, which was very small. We have small little standard deviation, which shows the level of what? Normality of the curve. But this curve can furthermore be described using the skewness and the kurtosis. In terms of skewness, we are talking about maybe there is the one part of it is different from the other part. It measures the level of asymmetry, meaning that it measures the level of difference between the parts of the curve, the right or the left. If it is skewed to the right, it means it is more tilted to the right, which is called positive skewness. If it is skewed to the left, it means it's more tilted to the left, which is called negative skewness. But the value of this can also be replicated in figures. Just click on Analyze. You go to Descriptive Statistics, you go to Frequencies. Of course, you go to Statistics. Then there's a part there, Skewness and kurtosis. Of course, I'm going to explain kurtosis later on. You click Continue. Then you OK. Now, look at the value of our kurtosis there. Our kurtosis here is 0.533. Our skewness is 0.533. Our kurtosis is 1.085. In terms of kurtosis, we are talking about the peakedness. That is, maybe the curve is flat or it has peak. A normal curve shouldn't have a peak and shouldn't be flat, but should be a bell shape. But kurtosis helps us to explain if it is either peaked or it is what? Flat. Now, from the value here, we can conclude. For example, look at the value of our skewness is 0.533. Any value not up to 1 plus 1, that is what plus 1 is 0 to plus 1 is positive skewness, and it is a normal distribution. It's fine. There is no problem of skewness. But in terms of plus 1, if it is greater than plus 1, it means there is a positive skewness. And from our data set here, we see that our value is 0.53, which is in between 0 and what? And plus 1, which shows that there is no problem of skewness with this data set. And of course, in kurtosis, it should also be for positive. It should also be between 0 and plus 1. But this is just a little above 1. We can really say that there is a slight possibility that this normal curve as presented here, this normal curve, that is a slight possibility that this normal curve have a little problem of kurtosis. So that explains what this means. In our next video, there's a need for us to see how these frequencies occurs and how cross tabulation, how they interrelate. So this will be discussed in our next video. Thank you.